Good day. Today we're looking at graphing sine and cosine. As you can see, I have provided you the graph for the sine function. Momentarily, I want you to fill out the chart in 1 through 8, but I'm going to start on cosine. Cosine has a little bit more of a trick than sine, so let's look at it together. On your unit circle, you have from 0 to 2 pi. You are in increments of pi over 2, so pi halves, 2 pi halves are just pi, and 3 pi halves. For the cosine function, that is the x values on the unit circle, I have 1, then 0, and then -1, and then 0, and then +1. This is the oscillation of my cosine function. So let us plot one period on this graph. 1, 0, -1, 0, +1, and so forth. So here is my graph of my parent cosine function. All right, from here, what is the domain of a sinusoid? I know it says cosine, but it's also the same for sine. Your domain is all real numbers. What is the maximum, minimum y values? That would be 1 and -1. The range is between -1 and 1. Inclusively, the period of cosine is 2 pi. Cosine is an even function. You could take this graph, fold it over the y-axis, and it would line up perfectly with itself. What are the x-intercepts or zeros? Now I'm going to skip this for a moment. Answer the y-intercept, which is just 1. Alright, x-intercepts. I want you to notice something special about sinusoids. There is an infinite amount of x-intercepts. So the question I'll pose first is what value of pi is the first x-intercept? Well, that would be pi over 2. Alright, let's look back up here. Where is the next intercept? That would be at 3 pi over 2. What is this distance? Well, 3 pi over 2 minus pi over 2 is equal to pi. So any increment of pi is another x-intercept. Here's how I write this for zeros. My first one plus k pi. All right, k means something specific in this. This is such that k is in the set of integers. So any whole number, positive or negative, I plug in for k, will be an x-intercept. All right, let's move on. You can read all of this, but I want to give you a full, well, maybe not full, but a slight insight into amplitude and period. Just a way to help you think about it. The amplitude is from the middle of your sine or cosine to the top and bottom. Now, the way I think about amplitude is with sound. Whenever we have a sound wave, the higher the wave goes, so while I'm talking, for example, I'm only going to be using the top part of the graph, it looks something like this. Whenever I talk louder, it goes up higher, and if I talk softer, it goes down lower. So, amplitude, the higher it is, the louder your sound wave is. How about your period? Your period is whenever it starts to repeat, is whenever your sinusoid enters a new cycle. Well, how does this relate to music or sound? Well, before I answer that for you, I want you to think about playing a YouTube video at 2 times speed. When you do, for example, my voice at 2 times speed would probably sound something like this. If you put it at 1/2 speed, it sounds something like this. What am I saying? Here's what I'm saying. The shorter your period is, the higher the pitch becomes. Go ahead and try it. Play this video at 2 times speed and see what I sound like. Alright, now that you've done that, go ahead and put it back to normal. And let's look at an example. Give the amplitude and the period. I'm going to do numbers 2 and 3. Number 2, the amplitude is the absolute value of A. In other words, it's just the 3. The period is 2 pi over B, which is 4. So my period is pi halves. Let's look at number 3. My amplitude is 1/2. My period is 2 pi over B, which is 2 pi. Now I'm going to do one of these graphs with you, and I'll let you try the other ones. I'm going to look at example 4, and I'll let you try 1 through 3. My amplitude is 3. My period is 2 pi over my B value 2/3. This is 6 pi over 2, or 3 pi. Alright, let's fill out my table. I know I'm going from 0 to 3 pi. For the middle, it's going to be halfway between them, so 3 pi over 2. If I divide this by 2, I can get my second and fourth point. So this is 3 pi over 4. This is 9 pi over 4. By dividing that way, you can see what increments you need to be going by. This is a sine function, so I'm starting at 0. I'm going to go down, because I have a negative in front of the 3, to my minimum of -3, back to 0, +3, back to 0. Okay, 0 to -3, to 0, to +3, to 0. I'm going to go ahead and put in my 3 pi over 4, my 3 pi over 2, my 9 pi over 4, and lastly my 3 pi. Here is my function over 1 period. Now you can follow this to get the remainder of this graph filled out. There we go, good enough, rough sketch. Go ahead and pause the video after try 1 through 8 up at the top, number 1, and then those 3 graphs. Here's your answers. That's all I have for you. Have a great rest of your day. Excuse me. Real quick, ensure you are in reading mode if you're using Desmos. If not, your graphs will not be correct. That's it. Have a good day.